Okay, so on Friday, we went through the parent graphs for both sine and cosine, right? We talked about how y equals sine of x gets its shape, right? This S shape is our parent function. It continues on forever in both directions. Okay, so let's talk about something here real quick. What would the domain of this function be? All real numbers. It continues on, forever in both directions. Okay. What would the range be? What? It would be negative 1 to 1. This curve continues to bounce between negative 1 and 1. Okay. So today we're going to look at how we actually get this shape to be in the correct range for our specific equation, and how we get the right shape for the period and all of that stuff. Okay. How about for y equals cosine? What's the domain for this graph? All real numbers. And its range is also negative 1 to 1. Okay. Now, even though the domain for each of these graphs is all real numbers, we are not going to graph all real numbers, okay? What I'm going to ask us to do, we're going to talk about graphing one period, maybe even a second period, and then we're just going to assume that it goes on forever following that same pattern in both directions, okay? So we're going to graph what's called the framing method, okay? What's going to happen is we're actually going to take these parent functions and we are going to imagine, and you don't need to draw this yet, I'll give you time to draw what I need you to. We're going to imagine a rectangular frame around it, and we're going to use the patterns and symmetry to get that curve the way that we want it to look. Okay? So the first thing that I do want you to take note of is how we start draw the frame. Okay, so I'm going to have you do this with me. Okay, so before you write it down, just drop your pencils real quick so I can explain it, and then I'll have you write it down. So what's going to happen is we have our starting point. This is not necessarily where our graph starts, it's where our frame starts. So we start drawing our frame at the starting point. We're going to go up and down the amplitude. Remember, the amplitude is half the vertical height, so we're going to have to use it to go up and down. And then the period is the length of the curve before it starts to repeat. So we're going to draw horizontally the length of whatever the period is. So then we have our frame, and I'm going to have you split it in half lengthwise, and then we're going to split it into quarters vertically. Go ahead and draw it, labeling period and the amplitude with all of those marks, so that when we draw the frame, you know this is what it needs to look like. Friday, we spent a lot of time figuring out how to identify everything. Now that we have that under control, we need to apply it to this frame so we can fit the curve inside. Okay. The best way to keep this as symmetric as possible, okay? Well, splitting it lengthwise isn't going to be bad. But to split it into quarters, my suggestion to you would be to split it in half and then split the halves in half so that you can keep the symmetry as symmetric as possible. Okay. And I'll show you how to do that with the numbers and everything else. But the frame and the dotted lines aren't really a part of our graph. It's just going to be a tool for us to get the curve symmetric and spaced out the way that we need it to be. Okay? So it's not actually a part of the graph. It's just there to help us. Okay? These dotted lines and the edge of the frame are going to help us place coordinates on our graph. There's going to be 5 coordinates I expect you to plot and label when you graph one full period of either a sine or cosine graph. Okay.
Can I interrupt real fast?
Sure.
Okay. Hi everyone. So we're collecting donations for the Special Olympics and for funds and stuff like that. So if you have any money or spare change, that will work if you want to be good humans.
If anybody has cash, get it out of your bags right now and give it to Becca Jackson.
Yes. Go, Jack.
Okay, I am giving you a handout so we can draw our general shapes.
Thank you guys.
Thank you. Okay. On this handout, it goes through what our steps are, right? We find the starting point by taking C over B comma D. We find the amplitude. Well, that is the absolute value of A. We find the period by taking 2 pi over B. Then we're going to construct our frame using those numbers. Okay? Well, then it says we need the horizontal spacing. So you're going to actually have to figure out what x values are at each of these quarter marks. All right? And there's 2 different ways we're going to do that. I'll come back to number 4 when we actually construct a frame of our own. And then we're going to plot 5 critical points. What I have this handout for you, well, first of all, it has those steps for you to reference as you are doing your homework, studying for your test, studying for your final, and we have to come back around to this, so keep this in a safe place. I want to go through what the shapes are going to be for each of the frames, okay? So there's 5 coordinates that every graph needs to have for the one period, okay? Let's talk about the sine graph with a positive A. Our sine graph looks like an S, okay? And it goes in the positive direction first. So our sine graph does begin at the starting point. Then we go to the next quarter mark and go to the top of the frame. Then we go to the next quarter mark to the middle. Then at the next quarter mark, we need to go to the bottom of the frame to make that S shape. And then at the very end, we come back to the middle. All right, so our sine curve with a positive amplitude should look like this. You gotta go over the hill first. Now, if we have a sine curve with a negative a, this is just going to flip upside down. So we are still going to begin at the starting point, but then we're going to have to go down first to the bottom of the frame, come back up to the middle, then go to the top of the frame, and come back to where we started. So we get that same S shape, but we have to go negative first because of the negative A. Okay. So as long as you have your frame drawn, we know how the curve is going to fit inside. Okay. All right, let's talk about our cosine curves. Our cosine curves are kind of our oddballs. Okay, cosine kind of gets to be different a lot of times during this chapter. The cosine curve does not begin at the starting point. So I need to reiterate, the starting point is not for the curve, it is for our frame. All right, the starting point is for our frame. But the cosine curve, remember how it kind of looks like a valley? All right, the cosine curve needs to start in the top corner. Then we come to the middle at the next quarter mark, then to the very bottom, and then back up middle to top. Okay. Make sure you pay attention to the curvature of this sine curve. Okay, we're kind of curving down, and then we curve up, and then we curve back down. Okay, so you kind of got to imagine that curve. It's going to keep going, right? And it has to round up here at the top on both sides. Okay, now if we have a cosine with a negative a, that is going to have to start in the bottom corner this time, and then come up at each quarter mark to make more of a hill shape. So a positive cosine graph, we're going to start in the top corner, but a negative cosine graph, we are going to start in the bottom corner. So now it's going to be a matter of putting this all together with what we did Friday and how to actually put the frame together and label our coordinates. Okay. To be honest, probably the most difficult part about this is actually labeling your coordinates, which really doesn't sound that intimidating. Okay. Going back to the frame that we just drew, okay, I want to go through again how we're going to draw that frame. If you want to write down the steps, go for it. Otherwise, you have that drawn as reference. Okay, but the first thing that you're going to need to do is you're going to need to, I guess it's right here. They're right here. I'm just going to go through them again. You don't need to write them down. Actually, if I were you, if you wanted to like tape or staple this into your notes, there's nothing we're going to do on the back, so you would be able to do that. Okay, I'm out of tape, but at the end of the period, if you want to staple into your notebooks, you could. Okay, so we're going to find the starting point and we're going to plot it. C over B comma D. You're going to identify the amplitude, right? And then we're going to draw up the amplitude and down the amplitude, okay, for our frame. Okay. You're going to identify the period, 2 pi over B. We're going to draw horizontally that length, whatever it may be. And then we can construct our frame with the split it in half lengthwise, split it in quarters vertically. Okay. For the vertical spacing, you can either, with your numeric values, find the middle, and then find the middle of the 2 halves, or you can split your period into quarters and add a fourth of the period to get to each mark. And I'll show you what both of those look like. Okay, I don't know if you can really imagine what that feels like until we actually do it. But I do expect 5 coordinates And I will ask you for domain and range on each of these graphs. Okay? Oh, that's a good idea too. Glue. I also have glue if you would like that. Okay? All right, so decide how you are going to store your blue sheet, and if you need to skip a certain amount of paper in your notebook. All right, but this is the first graph we're going to do. You can keep that blue piece of paper in your notebook. You can staple, glue, tape the blue paper into your notebook, and then continue on the next page, maybe for your example. I don't care what you do. I just want you to feel like you're organized. Okay? So go ahead and write this down, and I will give you about a minute or so to identify the starting point, amplitude, and period. It's awfully quiet in here, so I'm going to make you check it with a neighbor when you've got it. Just in case. Brecken, what is your amplitude?
1.
Our amplitude is 1. I am going to make a note that we do have a reflected sign graph because of the negative, but our amplitude is 1. Caden, what's our period?
2 pi.
2 pi. B is 1, so it does not affect our period. Our period remains 2 pi. Gracie, what about our starting point? Negative pi over 2, 3. Very good. C over B is negative pi over 2 divided by 1. And then our D value is 3. Okay? So this is what we are going to do. I'm going to draw this in green. Anything that I do in green is me trying to do it lightly. Okay? I can't differentiate dark versus light in when I'm up here. So green is just going to be my light color. All right? So our starting point is at negative pi over 2, comma 3. Okay? And to construct our frame, we need to go up and down the period. So if I go, up and down the amplitude. If I go up our amplitude, then what y value are we when we get to the top? 4. Because our amplitude is 1. And then we're going to go down our amplitude of 1. And so the bottom of our frame is at 2. Then we're going to draw a rectangle the length of the period. Not the greatest rectangle I've ever drawn. Okay, so I am first going to show you method number 1. Okay. This is an x value of negative pi over 2. The period is 2 pi. So if we begin at negative pi over 2 and we go to the right 2 pi, where are we stopping? Basically, you're taking negative pi over 2 and you're adding 2 pi. So 3 pi over 2. Okay. So then we're going to have to split our frame in half. And we know where that is vertically. It's at 3. Then we're going to have to split it into quarters. So let's just split this in half the first time. So if I split this in half, I want to know what the midpoint is between negative pi over 2 and positive 3 pi over 2. Okay, yes. If you need to go off to the side and do some scratch work, we have negative pi over 2 plus 3 pi over 2. That's how we would find a midpoint, right? Add them together, divide by 2. Well, when we add these together, we would get pi. So that's how we get pi over 2 for the middle. All right? Okay? Then we need to take each of these halves and split them in half. So what do we get as a midpoint of negative pi over 2 and pi over 2? Ooh. And what do we get for a midpoint between pi over 2 and 3 pi over 2? We would get pi. Once again, if you don't want to do it in your head, you can go off to the side and do some scratch work. We have to add the 2 together and divide by 2. That's how we find the average. So when we add them together, we end up with 2 pi divided by 2 to get the 1 pi. Okay? That is the most labor-intensive part of this whole deal, is getting the frame drawn. Now it's easy. Okay? Because all we have to do is draw in our curve. Now we have a sign that is reflected down. We have a negative sign. So the sine curve begins at our starting point, but then it dips down first to make the S shape since it's negative. Kelly, do you have a question? Mm-hmm. Okay. Okay. What I do want you to do, because I got a lot of numbers thrown up here, okay? I want you to go through and let's label all 5 of those points. So we have negative pi over 2, 3. Down here, we know this coordinate is at 0, 2. This coordinate would be pi over 2, 3. This coordinate is at pi 4. And this coordinate, 3 pi over 2, 3. Okay, look. So the height is 2, but then the x value is negative pi over 2. So this 2 is labeling like a y. Everybody, what's our domain? All numbers. For this particular graph, Jack, what would our range be?
Maybe 2 to 4.
Good. 2 to 4. Our frame vertically stretches from 2 to 4. That's our range.
How did you get this?
Since our period is 2 pi, wherever we begin in terms of the x coordinate, we need to go over 2 pi. So I just took 2 pi and I added it to wherever we started. That way I knew where to stop it. Okay? When we do our next one, I will show you, well, let's talk about that method number 2 real quick in terms of this problem. if we were going to do method number 2, our period was 2 pi. If we cut that into fourths, what would that be? It would be pi over 2. So if you wanted to use that second method, then what you would do is you would take 1/4 of the period, so in this case pi over 2, and you would just add it for each of the quarter marks. So you would have pi over 2 is 1/4 of the period. So you would add it and mark this as 0, and then add it and mark this as pi over 2, and then add it again to mark this as pi, and then add it again to mark it as 3 pi over 2. Okay? I don't care what method you use. Some of you are going to like the midpoints. Some of you are going to like just the basic addition. Okay? It depends on what you're comfortable with. Before we do another example, is there a question that you would like to ask about this sine curve? Yes.
So I know you said green is lightly. We're on the build a frame on.
No, you'll have to draw the frame.
And will you want all of those numbers on?
So for sure, I want to see the 5 coordinates labeled. I don't know how you would do that without doing a little bit of labeling here, but for sure I want to see those 5 coordinates. Any other questions? Okay, let's do another example. So go ahead and write this one down and identify for me the starting period, amplitude, starting point, period, and amplitude. I hear some people doing it already, but compare your 3 answers.
Period is 2 pi divided by 6, and the period is 5. Yeah. And your amplitude will never be
That's from that first week of school. All right. Our amplitude. Devin, what is it?
The amplitude is 2.
Good. The period. Kaylin, what's the period? 2. If we take 2 pi divided by b, we end up with 2 because b is pi, which is strange, but it happens. It's fine. Okay. Oh no. I was wondering if that was going to happen. Okay. Our starting point. Nathan, what do you have for your starting point?
Well, we kind of have some different answers.
Uh-oh, okay.
I got -3, probably -2.
Okay.
But I kind of like Emma's answer, and it's 1/3 -2.
Okay.
I think it might be -3.
Negative 1/3, negative 2.
Negative 1/3.
Okay, so if we're talking about C over B comma D, our C is a negative pi over 3, and our B is pi. So I would say that this does reduce to negative 1/3, negative 2. Okay? Because that's like multiplying by 1 over pi. So the pi's cancel out, but that 3 is still a denominator. Okay? Interesting. Okay, did that kind of make you feel uncomfortable that all the pi's canceled out? A little bit? Okay. Our process. Is this another? Oh, this is cosine. Okay. Our process is still the same. So our starting point is negative 1/3, negative 2. Okay. Well, now we have a taller amplitude. So, you know, I'm going to try to draw my frame a little bit taller. Some of you may not. It all depends on how much room you have. But I'm going to go up here. Where would my y value be at the top? 0. And at the bottom? Negative 4. Okay. And then we are going to go over the length of the period, which is 2. Now, I'm going to go ahead and take a class vote here. How many of you think that you like the method number 1 where we're going to find the midpoints? How many of you think you want to use that method? Okay. How many of you think you want to use the method of a fourth of the period added 4 times? You're about like 50-50. Okay. Well, since we did the other example with the midpoints to begin with, let's go ahead and do it the method 2 just so you can see the difference without the numbers already being up here. So if we decided to split the period into fourths, that would be just a plain old 1/2, right? Okay, so I'm going to go ahead and make my quarter marks by splitting in half and then splitting in half again. And then I'll label them according to our period. So our period is length 2. We start here at negative 1/3. When we add 1/2, when we take negative 1/3 and we add 1/2, what do we get? How many? If we take negative 1/3 and we add 1/2, this would be negative 2/6 plus 3/6, so 1/6, right? Okay. Now let's add 1/2 again. That would be 4/6. We'll probably call it 2/3. And then we're going to add 1/2 again. Seven-sixths. And then we're going to add 1/2 again, which would be 10/6 or 5/3. If we would have done it the other way, we would have taken negative 1/3 and added 2 to get to here. The midpoint, bless you, of 5/3 and negative 1/3 is 2/3. And then we would have found the midpoints from each of those. Okay? Either way, you're going to be working with fractions. It's just a fact. Okay? There is no escaping it, and it's not a scary thing. Okay? Now let's put our curve in. We have a positive cosine curve. Please remember, our starting point stays in the middle of our frame, and it's only where the frame starts. It has nothing to do with the curve. The cosine curve actually starts in the top corner of our frame and comes down and back up like a valley. Okay. So then we can label these coordinates. This is negative 1/3, 0. This is 1/6, negative 2. This is 2/3, negative 4. This is 7/6, negative 2. And this is 5/3, 0. I will warn you that your book is going to ask you to graph 2 full periods. Focus on this right here. And then for the second period, all you have to do is draw another frame without labeling it and draw your shape just one more time. I really only care about the labels on the first period. The second period is more so you can just see the shape continuing. Okay. Now, real quick before we break up here, our domain for any sine or cosine curve is going to be all real numbers. It's your range that you're going to have to be careful with. Okay. Our range in this case stretches from negative 4 to 0. Yes.
So like all my peers and all my classes, you have to do
I don't remember off the top of my head. What I care about is the first period. Okay. The second is more just like for the shape. Like you don't have to label the second period. You would just have to continue on that shape. Okay. All right. What I am going to do for you though, since the book does not use the framing method, and they're really just, it's going to look like they put it into their graphing calculator. That's what you're going to see in the back of the book. I will post my worked out graphs so you can look at your frame compared to my frame and make sure that your curve looks like mine in terms of the points labeled and the domain and ranges and that kind of thing. Does that make sense? Okay, so when you do your homework, you need to check your answers with my work. Okay? All right.